So today we are going to be talking about sequences of rigid transformations and congruence, and so go ahead and open up your book to page 43. So for our learning target today, we are going to learn how to explore the idea that a figure generated by a sequence of rigid transformations is congruent to our original figure, and then understand that a sequence of rigid transformations does not change the size or the shape of that figure. So when we have our sequences of transformations, that means that we have one or more transformations performed in a certain order on a figure. So for our example here, we see that Maria and Brian each perform a reflection and a translation. It starts with Maria reflecting figure C across the x-axis, like so, and then she translates it 8 units down, like so. So this would be the final part for Maria after she reflected and then translated it 8 units down for each of her points. From there, we see that Brian translated figure C 8 units down and then reflects it. So Brian starts by translating, so he goes 8 units down to make this new figure, and then he reflects that along the x-axis. So this would be his final figure. So the question is, will Maria's and Brian's sequences of transformations map figure C onto the same final image for C double prime? And our answer would be, we have our C double prime for Brian up here and our C double prime for Maria down here. So no, this means that the order of transformations does in fact matter. So it started with Maria reflecting and then translating, whereas Brian translated and then reflected. So their final images were at 2 different spots on the coordinate plane. So next we're going to graph a pentagon with these vertices A, B, C, D, E. From there we will translate that pentagon 4 units to the left, and then from there we will rotate 90 degrees counterclockwise and see if they're the same size and the same shape. Alright, so first we need to graph the pentagon. So we have our A is at 8, 0, so we go to the right 8, and then we go up 0, so there's our A. Then from here we have our B, which is at 6, negative 2, so we go to the right 6, and then we go down 2. So there's our B. And we have our C, which is at 6, negative 6, so we go to the right 6, down 6, so there's our C. And then we have our D, which is at over 4 and down 4, so there's our D. And finally we have our E, which is at the right 4 and down 0, so here's our E. And then we connect those dots in the order of which it says A, B, C, D, E. So A to B, B to C, C to D, D to E, and back to A. So that is our original pentagon right here. The next part we need to do is translate it. So we translate it 4 units to the left. So we're going to do that for each of our points. So A, we go 4 to the left. 1, 2, 3, 4. So here's our A prime. And then from there we have to do the same for our B. So 1, 2, 3, 4. So here's our B prime. Then for C we go 4 to the left. 1, 2, 3, 4. So here's our C prime. Same for our D. 1, 2, 3, 4. So here's our D prime. Then our E, we go 4 to the left. So 1, 2, 3, 4. So here's our E prime. Then again, we just want to connect those dots together. So A goes to B, B to C, C to D, D to E, back to A. So there's our new prime. That's after being translated 4 to the left. Then the last part we want to do is we're going to rotate it 90 degrees counterclockwise. When we go 90 degrees counterclockwise, that is the same as that negative y x. We have to flip the order and then make this value its opposite. And we are doing that on our new figure here. So we have our a prime is at 2, negative 2. So then when we rotate that, we have to switch positions. So now negative 2 is here, positive 2 is here. And then this negative 2 becomes its opposite, like so. So now that's positive 2. So now we have to the right 2 and up 2. So that's going to be our new b prime. So it's going to be written with the 2 things for b double prime. We're going to do the same for our a prime, which is at 1, 2, 3, 4, 0. So 4, 0 is going to become 0, 4. Since we can't really make 0 its opposite because it's not really positive or negative, it just stays 0. So we have 0 up 4. So there's our a double prime because it's been transformed twice. So we have our 2 primes. For our c, we were at 2, negative 6. And we flip those. Now negative 6 is here, 2 is here. And then we make what was our y value opposite, so now this will be positive 6. Then we go to the right 6 and up 2, and there's our new c prime. So c double prime. Then we have d, which is at 0, negative 4. So flip that order. Now it's negative 4, 0. And remember, we need to make this value its opposite, so now it's going to be positive 4. Then we go to the right 4 of 0, so now here is our new d prime. That's our d double prime. Then we have our e prime, which is at 0, 0. So if we rotate it, it will stay there, so now this is also our e double prime. And then the last part is we just connect it, like I said before. So a to b, b to c, c to d, d to e, back to a. So then here is our figure after it's been rotated 90 degrees counterclockwise. And so this is our sequence of transformations because we started with our red figure, we translated that, and then after we translated that translated figure, we rotated. So it's a sequence of transformations because we did one transformation and then a second transformation. But we can see that even though we transformed it twice in 2 different ways, it still stayed the same size and the same shape. So the answer is yes. So that's how we do that problem. You can see the picture of the final figure here. So we had our original here. From there we translated it to get our blue figure, and then we took that blue figure and rotated it to get our final figure in green. But no matter what, this original figure and our final figure are still the same size and shape. Next we have the connect it. So are they the same size and shape? So we already answered that. So yes, the sides and the angles of pentagon A double prime, B double prime, C double prime, D double prime, E double prime are the same measure as the corresponding sides and angles of pentagon ABCDE. So even though it went through 2 different transformations, it's still the same size and still the same shape. Now we have the look ahead. And so you already know you can transform a figure, so we've discussed this. And you can also transform the image, which is why we have that sequence of transformations. So after you do one type of transformation, then you do another type of transformation on that new one. And so you add a prime mark every single time you do a different transformation. So if we have this x that has these 3 prime marks, y has 3 prime marks, z has 3 prime marks, that means that there are 3 different transformations that took place. And we know this because of the 3 prime marks after each vertex label. So there was 3 different transformations because we have 3 prime marks per letter or per vertex. Next we have B. So when they are the same size and shape, they are congruent, which means that they are equal to each other. And so when a figure is translated, reflected, or rotated, it is always congruent and is always equal because it's always the same size and the same shape as the original. So that means that ABCDE and ABCDE prime are congruent, so they're equal to each other. And we would write it like so. So you put the equal sign normally and then the little squiggle over it. So we want to do the same thing to say that our A double prime, B double prime, C double prime, D double prime, E double prime is also congruent to A prime, B prime, C prime, D prime, E prime. So they're all congruent to each other. And we would write that like so. So you write it out, put your equal sign with the little squiggle on top, and then the other part. So that shows that they are congruent to each other. Then we have that Enrico translates figure Q to get Q prime, and then he rotates that Q prime to get Q double prime. So we know that they are congruent because the figure is translated, rotated, or reflected of the image or the original figure are congruent. So no matter how many rigid transformations you do, its size and its shape will still not change. So whether you reflect, you translate, or you rotate, the size and the shape will always stay the same no matter how many times you transform it. Last, we reflect. So how can you use a sequence of transformations to show that one figure is congruent to another? And so we can see that you can find a sequence of translations, reflections, and rotations that maps that figure onto the other. So if you did so many transformations, you would eventually get that new figure would be exactly on top of the original figure. So no matter what, we can check it that way. Last part is your homework, which is those pages 47 and 48. In your workbook, there's also going to be a PDF or Google Doc version available as well if you don't have your book. That's due tomorrow, Thursday, October 22nd at 9 a.m. This is what it looks like. So you have on page 47, you have translation, reflection, rotation we've talked about. So our 3 types of rigid transformations. You're going to say what they are in your own words and then have some examples here. For part 2, which is also on page 41, it's asking you to tell what type of transformation maps figure A onto A prime, and then you're going to either draw the line of reflection, the center of rotation, or a direction arrow to show if it was translated. So you're going to say what type of transformation took place, and then describe it in more detail. Then for number 3, we have a quilt has a border made of right triangles and trapezoids. So you're going to graph a triangle at these vertices, so you'll have to make your own little coordinate plane. You graph them at these 3 vertices, and then from there you're going to take that triangle and you are going to reflect it along the y-axis, and then you'll take that new triangle you just made and translate it 8 units up, and then discuss whether it is the same size and the same shape. And that it will be your homework.